Hello again. Today our topic in computer system architecture course is asynchronous data transfer. In the previous video, we discussed peripheral devices and input-output interface. In a digital system, the internal operations are synchronized by clock pulses, and they are usually supplied by a master clock pulse generator. The pulses are applied to all the parts in the computer system, interface unit, CPU, and to other parts as well. If the register in the interface and the CPU registers share a common clock, the data transfer between the two units is said to be synchronous. And this scenario is usually not used. And the reason is that the CPU and input-output interface are designed independently of each other. For this reason, the synchronous data transfer between the I/O interface and the CPU is not practical. When internal timing in each unit is independent from each other, in this case, the two units are said to be asynchronous to each other. This means that in the asynchronous data transfer, each unit has its own private clock. So we have private clock for interface and the private clock for the CPU. And this implies that CPU and I/O devices must coordinate for data transfer. Or we say that synchronization is required. There are two methods for asynchronous data transfer. The first is the Strobe, and the second is known as Handshaking. And really, these methods are used not only for I/O transfers, but they are general methods for transferring data between any two independent units. So in general, if we have two units, unit 1 and unit 2, and these units are independent, then for transferring data between these two units, these methods are applied as well. Any of these methods can be source initiated or destination initiated. So we have four scenarios: Strobe source initiated, Strobe destination initiated, Handshaking source initiated, and Handshaking destination initiated. In the Strobe method, a Strobe pulse is supplied by one of the units to indicate to the other unit when the transfer has to occur. The source unit, destination unit. The Strobe may be activated by either the source unit, in this case we have source initiated Strobe, or it can be activated by the destination unit, and in this case we say that we have destination initiated Strobe. The Strobe is a single line that informs the destination unit when a valid data is available in the bus. The data bus carries the binary information, and the Strobe, which is a control signal, informs the destination that a valid data is available in the bus. First, we start with source initiated Strobe. The steps are as follows. First, the source unit places the data on the data bus here. After some delay, to ensure that the data settled to a steady value, after a brief delay, the source unit activates the strobe pulse here. The information of the data bus and the strobe signal remains in the active state for a sufficient time to allow the destination unit to receive the data. The source unit removes the data from the bus after a brief period after it disables its strobe pulse. According to this procedure, we have one major disadvantage, that the source unit has no way of knowing whether destination unit received the data or not. Since in the strobe control, we have single control only. Regarding the timing diagram of the source initiated strobe, here we have the valid data and the strobe. And usually registers in the destination unit are triggered at the following end of the strobe. In the destination initiated strobe, source unit, destination unit. The destination unit activates the strobe pulse, informing the source to provide the data. The source unit responds by placing the requested data in the bus. The data must be valid and remains in the bus long enough for the destination unit to accept it. And again, the following edge of the strobe can be used to trigger a destination register. The destination unit then disables the strobe. The source removes the data from the bus after a predetermined time interval. And regarding the timing diagram, here we have the strobe before the data was placed in the bus. Valid data. In this slide, I brought both the timing diagrams for the source initiated and destination initiated strobes. Do you see in the source initiated, the data is placed in the bus, and after that, the strobe is activated. But in the destination initiated strobe, the strobe is activated from the destination first. After that, the source unit places the data in the bus. Next, handshaking. In real life handshaking, there should be a request from one source and acknowledgement from the other. The disadvantage of the strobe method is that the source unit that initiates the transfer has no way of knowing whether the destination unit has actually received the data item that was placed in the bus. Similarly, a destination unit that initiates the transfer has no way of knowing whether the source unit has actually placed the data on the bus. Handshaking solved this problem by introducing a second control signal that provides a reply to the unit that initiated the transfer. So in handshaking, there are two control lines, source to destination unit and destination to source unit. The two handshaking lines are data valid, which is generated by the source unit, and data accepted, which is generated by the destination unit. So handshaking may be source initiated and destination initiated. Source initiated, here we have the source unit and destination unit. Data bus, data valid, data accepted. And the steps are as follows. As in the Strobe transfer, the source unit initiates the transfer by placing the data on the bus and enabling its data valid control signal. After accepting the data from the bus, the destination unit activates the data accepted control signal. So in this case, the source unit is informed that the destination unit has received the data. The sending unit disables its data valid signal, which invalidates the data on the bus. And the destination unit disables its data accepted control signal. In this case, the system goes to its initial state. Here you can consider the timing diagram. First, the data is placed on the bus. The strobe is initiated from the sending end. And after receiving the data, the destination unit initiates the data accepted signal. And again, quickly the sequence of events in the source initiated transfer using handshaking. The source unit places the data on the bus and enables data valid control. After accepting the data, the destination unit enables its data accepted control signal. After receiving it, the source unit disables its data valid signal and the destination unit disables its data accepted signal. And therefore we return back to our initial state. And the destination initiated transfer using handshaking, the destination unit starts by placing ready for data control signal in the bus here. After that, the source unit places data on the bus and enable its data valid control. After accepting the data from the bus, the destination unit disables its ready for data signal and the source unit disables the data valid signal and we return to the initial state. The handshaking scheme provides a high degree of flexibility and reliability because the successful completion of a data transfer relies on active participation by both units. Consider, for example, the case of source-initiated transfer. After the source unit places its data and data valid signal in the bus, it waits for the data accepted signal from the destination unit. If after a certain amount of time, called timeout, it does not receive the data accepted signal, then the source unit can guess that the destination unit did not receive the data. In this case, the timeout signal can be used to interrupt the processor that causes an error recovery routine. Data transfer can occur in two ways, serial and parallel. A serial requires a single line, one at a time, while in parallel, multiple lines are used. Therefore, serial data transfer is slow, while parallel is fast. Serial transfer is economical. Parallel is expensive. In serial, usually we have less errors and the model is simple, while in parallel we have error prone and complex model. Usually serial transfer is used for long distances and parallel transfer is used for short distances. This is not a rule, but in most cases. Examples for serial transfer is computer to computer transfer, and examples for parallel transfer, computer to printer transfer. These are the main differences between serial and parallel transfer. For today, that's all. Thank you.